Okay, a couple announcements before we get going. Actually, a lot of announcements. So I mentioned last time about the JCreator bug. If your JCreator is not popping up a black command prompt window, then you're going to start having a lot of problems developing homework 2, which coincidentally is due this Friday at 10 a.m. Homework 3 is going to be somewhat similar to homework 2. It's still on using objects, and that's going to be due the following Friday. We're going to spend some time talking about it this Friday. In terms of scheduling, so obviously this week we have homework 2 due. Next week will be homework 3 due. The following week is going to be the first midterm. The drop date for engineering students, which is not all but most of you, is I think February 28th. For the college students, it was like a year ago. And we expect to have the grades returned and a rough idea of how you're doing in the class in time for the drop date, just as an FYI. So the Lab 1 and 2 grades have all been returned. I want to spend a bit of time talking about the regrade process once I get through this slide. I expect we'll probably finish Chapter 2, which is Java Basics using objects. We're going to get through most of that today. Starting on Friday, we're going to talk about decisions, which is if statements, switch statements, and such stuff like that. And that'll be probably most of next week as well. The lecture videos were online. We expect to be a bit quicker in the turnaround for it. So all the videos that are being recorded of me jabbering on during lecture are now posted up on the website. Let's see, survey results to talk about last time. I'm going to spend some time talking about the course project ideas that we had. Although the first thing I want to do, so I'm going to first talk about regrades and then about the course project ideas. Before I do, any questions, comments, concerns? Okay. So regrades, we talked about this briefly before, but now that we have some assignments that were actually returned, we can talk about it in more detail. So if you go to the course webpage, the submit page, submit a regrade. If for whatever reason you feel that your grade on a returned assignment, lab, quiz, homework, was unfair, and unfair meaning, you know, we specify the grading guidelines, and that's listed in the email. And if you feel that we did not follow the grading guidelines for you, or you have a special case or something similar, please fill out a regrade. User ID, password, what assignment this is, and a reason. And the reason, so a suggestion as to reasons that are good reasons. You took off points for not including my name, but my name is there. Or, you know, I think you were too harsh on this grading, or you missed that. Things like, oh, can I have more points, please, is not a valid regrade reason. This is not a chance for you to do the assignment again. It's just a chance to make sure that we are fair in terms of our grading. I think the TAs do a great job, but we're, you know, 20 different humans that are doing the grading, and everybody misses some things. I probably miss more than most. So that's essentially the purpose of the regrades. I will tell you right now that my first priority in this class is not in terms of regrade speed. Any regrade you submit will get looked at. It will get looked at fairly. It just might take a little while. Just because my first priority is getting labs out in time, the homework's out in time, the test is done, and lectures, and making sure the website's updated, the email. Regrades may take a while. I would think, you know, within a couple weeks you should hear back. But if it's taking a bit longer, I mean, as long as it's in the system, it's not going to disappear. But just keep in mind that that's, in the grand scheme of things, you know, getting the lecture ready is obviously more important than the regrade. So they will get taken care of. Regrades have a fixed amount of time. It lists which assignments are available to be regraded. And for example, these can be regraded until about the middle of the month. If you submit a regrade and you get it returned to you in, I don't know, a couple weeks, and you don't like what we said because you feel it's unfair, then feel free to swing by my office hours and we can talk about it. Okay. Also, on the submit page, there's a view your grades page, which I can't really do much because obviously I don't have grades or me for this class. But if you actually enter your username and password, it will list all of your grades so far. Right now it's a whopping 2 labs. But, you know, once we start getting moving in the semester in terms of assignments being returned, all of your homeworks, lab quizzes, exams, everything will be listed there. The thing to keep in mind is, the other thing is that once we get through the first midterm, it will actually list the current course average as well. So it will sum it all up and tell you the weighted average so far. It doesn't really make sense to do that at this point because I'd say 90% of the people here have 100% average because you got 4 out of 4 on both labs. So once we have two homeworks returned and I think the first test returned, it'll actually tell you the running course average as well. So some people ask, we are going to keep the grades in Toolkit during the semester. Once the semester's over, the grades will be moved into Toolkit. Other questions or comments about this? Okay. So there's a couple, I want to spend some time talking about the course projects. And these are sort of the 4 that we are considering, and I'm going to spend some time sort of talking about each one. Let me give a couple disclaimers first, and I want to make sure these are pretty clear. Whatever game we do, it's going to be text-based, which means you're going to enter input into, by text, and you're going to get text responses back. So it's not going to be graphical. It's not going to be pretty colors. It's just going to be a text-based game, which is not a bad thing. In fact, we've had some pretty interesting text-based games. Just keep in mind that some of the things I'm going to show are like Civilization, but those who played it have really nice 3D graphics. I mean, obviously, that's a bit beyond what we're going to be doing in this course. So the first one that I wanted to spend some time talking about was something called Hunt the Wumpus. This is a game from like the early 1970s. And, it's a text-based game that, if I could get this to work right, it's basically a dungeon crawl where you have to move through this area that's there's 20 connected rooms, and you have to hunt the Wumpus. And a Wumpus is some mythical beast that basically you're trying to slay. And you have 3 arrows, and you basically walk around trying to find the Wumpus, and you shoot arrows into adjoining rooms in order to hit the Wumpus. In particular, if you walk in upon the Wumpus, he eats you, and that's not obviously what you're going for. There's a couple other hazards as well. There are pits, and if you walk into a pit, you fall down, and the Wumpus comes and eats you later. And there are bats, and if you walk into a room with a bat, it will pick you up and drop you off in some other random room. But the thing is that there are clues. If you are in a room that's next to a room that has a pit, it's going to say you feel a draft. You don't know which room has the pit, but you know at least one of the 3 adjoining rooms has it. If you're in a room that's next to a room that has a bat, you're going to say something like, it stinks of bats in here. So again, you don't know which room it is. And I think if you're right next to the Wumpus, it gives you a warning as well. So you basically have to walk around and you figure out, well, what is the, figure out where the Wumpus is, avoiding the bats and the pits, and eventually you shoot an arrow and hopefully hit the Wumpus. And if you miss it, then he comes charging after you and eats you. So I personally find this a particularly entertaining game because this is like one of the first computer games that there ever was. And let's see if I can type upside down. 3. So although you can't, it might be kind of hard to see. Oh, the network just died. There we go. So as we do this, there's going to be sort of 2 different maps. In terms of the version that we in this class will implement, there's going to be 2 maps. One is sort of the original map, which is 20 rooms, each room connected to 3 others. The other is going to be sort of a square grid because when we talk about 2D arrays. So I'll just pick, I don't know, dodecahedron. So in each room, it tells you there's 3 things you can do: shoot, move, or quit. Shoot means you shoot an arrow, and you shoot into 5 adjoining rooms. And if you mention the room that you're in, you kill yourself. Quit, of course, means you finish the game, and move means you move into some other room. And I'll just move to a couple rooms. Let me see if I can hit something interesting. So I'll move to, so it also says here what the adjoining rooms are. Oops, come on. I can play a game. Et cetera, et cetera. And obviously I don't know where any of the things are because the Wumpus and the pits are sort of randomly located. So this is one option. it is currently the option we are leaning towards because, well, for a number of reasons that I'm going to come back in a second. So that's one option. The next option is the Oregon Trail. How many people have played the Oregon Trail? Right. Okay. Here's the thing. The version that we do here is going to be very heavily modified. So the version that you find online, in fact, we could find it online here, but it doesn't like to work with Firefox. So, yeah. And I took the plunge and forced myself to load up IE. So the Oregon Trail that you're used to and that you can play online, and if you feel like playing this online, in the daily announcement slides, it actually has links to this. It had, for the time, really cool graphics. This was in the, well, first came out actually in the 70s as well, but then it was all text-based. And, all right, let me pull up some of these really cool graphics. No? Come on. All right. Blah, blah, blah. So basically, the idea of Oregon Trail, for those three of you who haven't played it, is you start in Independence, Missouri. Independence? And you need to get to Oregon. And you start sometime in the spring, and you buy wagons and oxen and have various family members or other people riding on, and you buy food, and you move across the country. And running into hazards, having such problems like dysentery, or your oxen can drown in the river, or there's such interesting things like that. And it's basically a challenge to get across. And it was actually an education game because it was meant to show elementary school kids sort of the problems that people really encountered on the Oregon Trail. Because we hear about the gold rush, and it was so, except for the one family that ate each other, was really like, grand, and everyone was going out to get their riches, and this kind of said, well, not really. These graphics is well beyond what we're doing. So if we do the Oregon Trail, A, it's going to be very heavily modified, and B, still no graphics. Okay. Next up is some sort of Civilization-like game. And Civilization is a game that came out in the mid-'80s, and it's a strategy game, and it has a huge amount of complexity to it. Again, there's a limit to how much we can actually do in this class. But the idea in these sorts of games is that you are oh, come on, you can scroll faster than that. Well, that's a nice size screenshot. But the idea is that there's some sort of landmass. You start out as settlers in 4000 BC, and you go found a city, Rome, New York, whatever you want. And you research technologies, you figure out writing, bronze working, nuclear technology, and you start creating more cities and sort of building a bigger civilization. At that point, you run into problems like pollution, or other neighbors, or barbarians, et cetera, et cetera. The idea is, as a strategy game, we sort of build up an empire. We're still sort of debating how feasible this is, but this is one thing we're looking at as well. And then lastly is, somewhere, oh yes, Connect 4. I really don't want to do this as a course project, but if everybody here wants to do it, I'll hold my breath and figure it out. But Connect 4 is you have a whole, this sort of grid, and different players alternate dropping in red or white or whatever color they are, circles into it, and you need to connect 4 either horizontally, vertically, or diagonally. So, I want to do it by a quick show of hands now, just to get a rough idea. But what's going to happen is tomorrow in the lab, I'm going to have additional questions sort of saying, which one of these would you like? And I'll probably send out an email saying, just think about it tonight. So if everyone could vote for one, how many people would say Hunt the Wumpus? Okay, Oregon Trail. Civilization. And Connect 4. Okay. So currently it looks like Hunt the Wumpus and Oregon Trail are the highest, but what we'll do is we'll have a nice breakdown of this. Well, I'll have a breakdown On Friday, I'll have the 101 students. On Monday, I'll have the 101, 101E students. Let me mention one other quick disclaimer, and then I probably should get into actual computer science today. We're not guaranteeing that that's the one we do. This is a project that you guys are going to be spending a lot of time on, so I'd like it to be something interesting. If you all vote for, say, civilization, and we realize that it's just not going to work out well, we'll take the next highest choice. So we're certainly going to take your votes into account. I can't guarantee that that's what it's going to be. All right. Questions, comments, concerns? And if anybody does have any other ideas for course projects, feel free to send them along. You probably have to send them along tonight, actually. So in the past, the problem is that every semester the homeworks in this class have to be different. In the past, actually the first time, this is the fourth semester we're doing this course project. The first time was a dungeon crawl game where you sort of had some map of a dungeon, went around fighting monsters and picking up loot. The second was an economic trading game where you move from one location to another, buying and selling things. Some markets sold things, was really inflated. Some was less inflated. And you could everyone could customize their game so they could be flying from different planets or selling textbooks around UVA dorms, what have you. Last semester we did Battleship, the game of Battleship. So anyway, that's sort of a brief history of the ones we've done so far. So last time we were talking a bit about overloading. And I want to briefly remind you what overloading is. There are a number of methods. One example is a value of method. And they take in different sets of parameters. The value of method, for example, can take in an integer, value of 3. That's going to create a string that has a single character, which is the character 3. 3.5, that's a double. So that's going to create a string that has 3 characters, so 3, a dot, and a 5. It can take in a character, can take in a Boolean, pretty much anything. Notice here that we have a single named method, value of, that will operate slightly differently depending on the parameter list. Okay, there's only one parameter, but Java knows what type it is, int, double, character. You can also have a method that takes in a different number of parameters. Substring, for example, can take in 1 parameter or take in 2 parameters, and it behaves differently depending on how many parameters are passed into it. This is called overloading. So called because it's given many loads or this particular name, value of, is giving many loads or many different things that it can do. Somewhere there are separate definitions for the value of method that takes in an int, that takes in a double, that takes in a character. So this is overloading. We talked about the plus operator. That can do many different things. It can do integer addition. It can do floating point addition, add 2 doubles. It can do string concatenation. It has multiple things that it can accomplish, and as a result, it's also called overloaded. Right. Blah, blah, blah. So I want to spend a bit more time talking about methods. There's some somewhat arcane terminology that I'm not a huge fan of, but unfortunately you're going to see it a lot. So you could arguably classify methods into maybe 3 or 4 categories. And these categories, for the most part, are just for humans to talk about. Java couldn't care less if it's an accessor, a mutator, or any one of the other categories. But one of these categories is an accessor. An accessor, as its name implies, allows you to access some property of that object. So it's basically some method that will tell you some information about that about that object. For example, in a rectangle class, rectangle r equals new rectangle, you can say r.getWidth. The getWidth method will tell you what the width is of that rectangle. GetHeight tells you the height of that rectangle. Another way to phrase that is the getWidth method allows you to access the width property of the rectangle object. So these are called accessors. Generally, although not always, but for the most part, they start with get, because you're getting some property of that object. Get width, get height, get radius, obviously not for rectangles, get color. So this is called an accessor. And, right. Again, the accessor notation, or the accessor classification, is just something for us humans to talk about. Java couldn't care less if it's, you can call it an accessor all you want. Java doesn't care. It's just a way that we classify it. Right. Usually starts with get. I'm not going to use this terminology a huge amount, but there are times that it comes into play, which is why I'm spending some time introducing it. Well, next up is mutators. Oh, question?
About accessors, do they bring anything up onto the screen? Do they just allow us to see what kind of object? Like, if we want to find out information about an object, it just tells us, okay, well, this is the object you're looking at.
The question is, does it bring much on the screen, or does it just tell you something about an object? You could say int x equals r.getWidth. Here you have some rectangle object r, dot means follow the reference, getWidth is the accessor method. This here will give you a value, 17, and then that'll be stored in x. Right? So x is then some variable, 17. You could then print that out to the screen, of course, x. So you can then print that out to the screen. You can also, get an eraser, you can also combine this into one line, and instead of saying print x, you could say print r.getWidth. That'll do the same thing. And your system.out, that print line, just print out whatever r.getWidth value it gives you. So the corresponding one to accessors is called mutators. Mutators allow you to mutate or change an object. So it allows you to make some sort of modification to that object. In particular, we saw in previous slides a setLocation method. The setLocation takes in two parameters, an x and a y, and it will set the upper left corner of the rectangle to whatever parameters you sent in. So you are calling you're saying r.setLocation, giving it two parameters, 3 and 5, whatever you want, and it's going to actually modify the values in that object. The object itself will be modified. So previously maybe it was at the origin, now it's going to be at 3, 5. So here a mutator allows you to mutate or change an object. When I say mutate, I mean change one of the properties of an object. It's still the same object that was there before, but you're just changing some property of that object. Accessor allows you to get some property of an object. Mutate allows you to set some property of an object. Correspondingly, they usually start with set in the method name. Set width, set height, set location, set bounds, set radius, set color, something that will take in some parameter and modify the object accordingly. If you say r.setColor, blue, it's obviously going to take in some color, and we'll see later how to specify colors in Java. It's going to take in some color and set the rectangle's color, the circle's color, whatever object you're talking about, to blue. Oh, well, I'm not using that one. Free cough drop. So that's mutators. Next up is constructors. A constructor is a very special method. And I mean special in that it has a very specific use. A constructor is used to construct an object, hence its name. It's only used when you are creating objects or constructing objects. That's the only time you ever use a constructor. Anytime you create an object, you must call a constructor, and you only call a constructor when you're creating an object. As far as we'll see in this course, the name of the constructor is always the same as the name of the class. Rectangle R equals new rectangle. The second rectangle in that line is the name of the constructor. It's a special method used to first help create or construct a given object. Scanner standard in equals new scanner system.in. So we've seen a lot of this, we've seen a lot of this terminology before, this particular line before, and what's highlighted in yellow is the constructor itself. There's a lot of other stuff going on here, right? This is creating the reference, this is saying I want to create a new object, and this is calling the constructor. In particular, the constructor takes in one parameter. That parameter is the keyboard, or system.in. So it looks kind of like another method. It has a name, it has parentheses, it has some sort of numbers in the parentheses. String foo equals new string hello world. Again, there's our constructor. It takes in this case, one parameter, and will create a new string object that happens to be the 11-character string hello world. We're going to talk a lot more about constructors in a bit. In fact, throughout this course, we're going to spend a lot of time talking about constructors. You can overload constructors. Remember that when we created a rectangle, we could say rectangle R equals new rectangle 1, 2. We're giving it 2 integer parameters to rectangle, and that sets the height and the width to 1 and 2. Or we could say rectangle R equals new rectangle 1, 2, 3, 4, and that's setting the height, width, x, and y to 1, 2, 3, 4. Oops. So this first one creates a rectangle that has zeros. X and y location is 0, height and width is 0. And this sets the x and y location to those and the x and y to those. So notice that we have two constructors, or two methods of the same name, rectangle and rectangle, that operate differently depending on their parameter list. Well, imagine we had a class called Circle. We're going to see a Circle class a lot later in the semester. But imagine we had a class Circle. We wanted to create a new circle. Circle C1 equals new circle. And that sort of follows the normal object creation lines we've seen. This does 4 things. We talked about 3 of them before. I'm going to now mention a 4th, if I can stop coughing. So the first thing it does, it creates the C1 reference. That C1 reference is created. It then creates the circle object. Somewhere in memory, it creates a circle object. And that circle object looks like this. As we're going to see, circle objects have a radius, pi. These are sort of properties of a circle. Sure, you could have color, line thickness, position, and a whole bunch of methods as well. It next makes the C1 reference point to the circle object. In particular, this is sitting somewhere in memory at some memory address. And that memory address is going to be copied into the C1 reference. So the C1 reference now points to the newly created circle object. The last, and those 3 that we've talked about to some extent previously. The last thing it does is it calls the circle constructor. This part here tells Java that I'm going to call the circle constructor that takes in no parameters. Come on, there we go. That part right there tells Java to call a circle constructor with no parameters. And the purpose of a constructor is to initialize the properties of an object. Maybe this circle object needs to have its radius set to 1. Maybe it needs to have the diameter set to 2 times the radius. Who knows? But the purpose of the constructor, as we're going to see, is to initialize or set up that particular object. In the rectangle version that we saw before, rectangle R equals new rectangle 1, 2, 3, 4, the purpose of that rectangle constructor was to set the values 1, 2, 3, 4 into the x and y location, the height and width. Well, here, the purpose is just to initialize the properties of the circle object. The constructor is always, always, always the first method called when creating an object or constructing an object. So let's say we wanted to create a circle object this way. And notice now the difference is in yellow. I'm now providing a radius for that circle object. I'm now creating a circle of radius 2, diameter 4. Again, this does 4 things. Creates the C1 reference, creates the circle object, makes the C1 reference point to the circle object, and now it calls the constructor with one parameter. Specifically with one double parameter. Because it looks at this part of the code right here, it looks at that and says, well, you're supplying one double parameter to the constructor, so now I know which constructor to call, because it turns out there's a half dozen in the circle class. So it calls the constructor with one double parameter, and this radius right there is now going to be set properly. Again, construct is always the first method called. So it turns out that there's 2 types of constructors. I'm mentioning them to you now so that you're aware of the difference. We will see exactly why they're called this later on in the semester. But the 2 types are default constructor or specific constructor. Default constructor is the constructor that takes in no parameters. If there are 0 parameters in the constructor, it is the default constructor. And there can only be 1, maybe 0. But kind of like Highlander, there can only be 1. Specific constructor, blah, blah, blah. Specific constructor takes in 1 or more parameters. And there can be as many as you want. At this point in the class, the only thing I want you to keep in mind is that there are 2 types of constructors. Why they're called that, I don't want to get into now because it's a long tangent that's not really necessary at this point. But the default constructor takes in 0 parameters. The specific constructor takes in 1 or more parameters. And you can have 1,000 specific constructors if you so wanted. Right. So we have 3 types of methods: accessors, mutators, and constructors. So then they basically take, accessors, mutators, constructors, and they basically said, well, let's have a 4th type called, default and specific. Let's have a facilitator. All a facilitator is a method that is not any of the other 3. It's a catch-all. If you're not an accessor, and you're not a mutator, and you're not a constructor, then you're a facilitator. It's just a sort of fancy term used to describe anything other than accessors, mutators, and constructors. So one of the things I wanted to briefly mention is Java documentation. But Java documentation, it takes a bit of time to read it and to read it well. It's a bit cryptic. We mentioned it briefly in the homework, so we're going to spend some more time in labs talking about it. But essentially, all of the classes that we are using, vector, string, scanner, system, math, rectangle, I'm trying to think what others we've seen that are in there, all listed there somewhere. And if you take this slide, basically in this, you can't really see it that well, in that part right there, lists all those classes. And there's about 4,000 classes. But you can actually look up the string class. And if you look up the string class, you can look up the index of method. And it will give you more detail of the index of method than you probably ever wanted to know. And the problem is that having 4,000 classes all sort of grouped together is a bit much. So I'm going to go back a slide. What happens here is we have packages. We've seen packages before briefly. Java.util, right? Import java.util.star. That allows us to use a whole bunch of classes in the java.util package. scanner, vector, string buffer that we're going to see in a little bit. Well, it turns out there's 50 or 100 different packages. There's only a couple that we're really going to need in this course. We've seen java.util. It's called that because it has a bunch of utility classes like vector and scanner and string buffer and some stuff that you're going to need for the next homework. Java.lang, that's all the class, that's automatically imported, so you don't have to say import java.lang.star. But that has such useful classes as math, system, and that's all we've seen. And at some point, we're going to see java.text much later in the semester. So if you find that the number of classes in the lower left is a bit much, you can just look at java.util or java.lang. Okay. Change. When the winds of change blow hard enough, the most trivial of things can turn into deadly projectiles. I guess this isn't the most appropriate after the storm that went through Florida. Part of the problem is I have all these selected like weeks ahead of time. Planning. Much work remains to be done before we can announce our total failure to make any progress. Not so funny. Laziness. Success is a journey, not a destination, so stop running. That's also one I'm not going to hang up in my office. Potential. Not everyone gets to be an astronaut when they grow up. So, I'm sure everyone's heard about astronaut A that started stalking and astronaut B because she thought it was competition for astronaut C. And again, I had no idea that this was in there, but it seems almost strangely appropriate considering all the astronaut love triangle news. Anyway, I've debated whether or not to show this slide in class. I also show it because I do believe that all of you do have the potential to be more than a fry server when you get out of college. So I think it's safe to show it. This one actually, one year was like so far and away the most favorite. I think it had like half again as many votes as like the second place one. But no, that's not going up in my office either. Yeah, sorry. You can get one put up in your office or dorm. Okay. So I want to spend some time giving a quick example. I don't want to spend too long on this. Giving a quick example of last semester's homework 2. In the past, we called the programming homeworks J homeworks because they were programmed in Java. We've gotten rid of the J moniker. So you can actually look online. Somewhere on my website is all the, like every class I've taught, everything's there. And essentially, this used the string buffer class. And it listed 10 steps to be performed. You notice that this seems kind of similar to your homework 2, which used the vector class, and had 15 steps. You notice we're getting harder. I'm sure you'll appreciate that. So the idea is that we want to introduce them to this class called string buffer and do a whole series of things using the object. So to create a string buffer object or two and start calling the methods out of them. Right. And you can find the excruciating detail about the string buffer online there. So one of the interesting things about string is that they're immutable. That means once you create a string, you can never change the string. You can create new strings. So when you take two strings and you add them together, it doesn't actually change any of the existing strings. It just creates a new string. This is done largely for efficiency reasons that we're not going to get into. But in particular, the string class has no mutator methods. There are no methods in there that will allow you to modify an existing string object. So in comes the string buffer class, which allows us to modify, which is a string buffer is much like a string, but it allows us to modify it in place. It just turns out that a string buffer is a lot slower, which is why people usually use strings when they can. All right. So it's also in the java.util library, so we have to have that import. And there were essentially 10 steps. I'm going to go through them fairly briefly because this in the past has not been the most exciting part of the lecture, so I don't want to spend too much time on it. But the idea is that the user needs to enter a couple strings. They need to be read into the keyboard. And in particular, they need to do a long string and a somewhat short string. And the short string needs to be contained in the long string. So essentially, here we enter the long string. We read it in. You notice here we told them to use next line because scanner wasn't quite as finicky back then. Oh, go away. Enter a short string and read that in. So at that point, we have two string objects, long string and short string, which have, not surprisingly, a long string and a short string. So what we needed to do is create a string buffer. And the way you create a string buffer, again, I'm going to kind of summarize the bullet points there, but this was the full description that was listed in the homework. You had to create a string buffer object. String buffer equals new string buffer. You'll notice for the constructor, we pass it in a string. In particular, the string object that we want the string buffer to hold. So now we have two objects that have the same text. A string object, long string, that has, I don't know, hello world. And a string buffer object called buffer that also has the same text. And it turns out that there's multiple ways to go about creating string buffers. In the previous slide, going back, we created it and we used a specific constructor, meaning the constructor that takes in one parameter. And that one parameter was the string that we wanted to initialize the string buffer with. Well, it turns out you can also call the default constructor, which is the constructor with no parameters. That creates an empty string buffer. Empty meaning it doesn't have, it's like a string with 0 characters. And then we call the append method. From the buffer object, I'm going to call the append method. That's going to take, imagine that's not really there. That's going to take the particular, let's try this sentence again. The append method takes in some string and puts it onto the end of the string buffer. So we've created a string buffer that's empty on this line. We're then going to add long string onto that. Either way is fine. We just wanted the students that semester to see both. So now we have to search one string for the other. And you'll notice that this uses an index of method, which is surprisingly similar to the index of method in the string class. They do the same thing, it's just they're used in different objects. But essentially, it's going to search buffer for the shorter string. And if you remember, when we asked the user to enter the objects, enter the strings, the short string had to be contained within the long string. Whoops. So now we have a position integer. We're going to remove that part of that string, that short string, from the middle of the long string. And essentially what we do, so if it was, I love cs101, so that's the long string, and the short string is just love, it's going to delete that from the middle of the string buffer so that the resulting thing is just I cs101. Okay, that example doesn't make perfect grammatical sense, but you get the idea. And that's calling the delete method. From the string buffer, there's a delete method. It takes in a position, which is the first character it should start deleting, and keeps deleting until it hits, the first index at which it should start deleting, and keeps deleting until it hits the second index. So position is where that string is found. We found where love is in the string, so that's about the third character. And position plus the length of the string, or position plus 4, because love is 4 characters long. We can insert strings into the middle of a string buffer. So again, at that position, I'm going to insert cs101. So now my string is I cs101, cs101. Somebody probably should have figured out his example before he went through this. Anyway, the insert method takes in the second parameter and sticks it at that position. It moves the rest of the stuff over. So the step 7 is to remove the last string from it. So it basically, so it's I, cs101, cs101. You find the position of the last space. That's done with last index of. Index of starts in the beginning and searches forward. Last index of starts at the end and searches backwards. And then we're going to delete everything from that space until the end. So then all of that's deleted, and at this point my string is I cs101. Append the word rocks on the end. So it then becomes I cs101 rocks, and that's using the append method. That was an I, really. Take out a character right in the middle, so that's going to take out I c101 rocks or something like that. Some character in the middle is just spontaneously removed. And then it reverses it. And reversing it, let's see. I c101 ROZ. Score 101 CI. And again, this is calling the reverse method. Why did I go through all that detail? Well, the point that I wanted to show you is that there are a lot of very useful, there's a lot of very useful classes contained somewhere within Java the Java library. And if it so happens that you need to do string manipulation, the string buffer class is one that's particularly good for it. It allows you to reverse strings, to take out something in the middle, stick something at the end, whatever you want. And this was essentially the homework from a couple semesters ago. Again, the way a lot of this works is you create an object, you created a buffer object, and then you manipulate that object by calling methods out of it. We call the insert method, the delete method, the reverse method, et cetera, and you're calling a whole series of methods out of it to accomplish some task. Well, here the task was set out in the 10 steps that we provided, but still some task was being accomplished. I'm not going to actually go through in a run of it, but the code is online in case you do want to see it. Yeah. Somebody has way too much free time. So, wait, give me a second. This finishes chapter 2. I am very purposely talking about things slightly differently than the textbook, because I think that gives you two perspectives on the same material. And I actually think that will help. Starting on Friday, we're going to start chapter 3, which is if, and I'll see you all then.